All right, so a few words about what's going to be happening in the lab exercise this week. In both this week's lab exercise and in next week's lab exercise, what we're going to be doing is we're going to be implementing an algorithm to solve a moderately complex problem. This week's problem is the problem of finding a path through a maze. And the problem begins with a text file that your program will be opening up and reading. And in that text file will be a representation of a maze. All right, so this is the text file that your program will be reading its information from. And on the first line of the text file, there will be a couple of numbers that give the dimensions of the maze grid. In this case, we're looking at an example of a maze that has 9 rows and 13 columns. And the program that we end up writing should be able to handle any size maze that we provide to it in the input. Now, after the first line, which gives the size of the maze, the remaining lines in the text file will contain the actual contents of the maze. And we're going to be representing the maze using a system of characters, and each of these characters has a specific interpretation. So first of all, the sharp characters that you see here, they represent walls in the maze. These are basically areas in the maze that you cannot enter. Then the O characters that you see, those represent open spaces in the maze. Those are places that you can travel to within the maze. Then in addition to those, there are 2 more special characters. One other special character is the character E that will appear somewhere on the boundary of the maze. That marks the entrance of the maze and where you're going to be entering the maze and starting your search. And the second special character that you'll see here is somewhere again on the boundary of the maze. There will be an X character that marks the exit of the maze. Right? And our goal is to find a path from the entrance through the maze, eventually toward the exit. Right? Now, to complicate things, what we're going to be seeing here are a number of features that you typically will see in mazes. One of these features is blind alleys. For example, this cluster of characters here, which has a series of O's leading up to it, these characters basically represent a dead end in the maze. And one thing that we're going to have to contend with is that we very frequently will find ourselves wandering off into parts of the maze that end in a dead end, and we'll need to have some sort of effective strategy for dealing with those situations when we come across them. Another feature that you frequently find in mazes is mazes very often are constructed in such a way so that there's the possibility that you could accidentally end up running around in circles. For example, there's a part of the maze here that consists of this stretch of open cells, this stretch of open cells, and these 2 that connect things together. And once you get into that region, there is the possibility that if you don't watch what you're doing, you could end up going around in circles. And if you're not careful about managing that, you could literally end up running around in circles forever and not ever making progress toward the exit. Right? So whatever strategy that we develop for finding our way through the maze is going to have to cope with those 2 specific features. It's going to have some strategy for dealing with dead ends, and it's also going to have some sort of conscious strategy to keep you from running around in circles forever and not making any progress toward reaching the conclusion of the maze. All right, so that is the problem that we're going to be solving in this week's lab exercise. And the next thing that I've done for you is I've done quite a bit of work already to set up the classes that will be necessary to implement this solution. So next, let's take a look at the project that I'm going to be providing to you as a starting point for solving this problem. What I've done here is I've constructed 3 separate classes, each of which is going to play a role in representing what's going on in the problem and making progress toward the solution. The first class that we're looking at here is a maze class. This is a class that represents the maze itself. And the most important thing going on in the maze class is that it will be storing a 2-dimensional grid, which represents the actual maze that you're going to be walking around in and working with. Right now, the individual elements within that grid are going to be made up of another type of object that I've introduced, and that is this cell class. In the original text file, when you look at the original representation of the maze, in the original representation, each cell in the maze is simply represented by a single character. All right? And again, the characters have specific interpretations where sharps are wall segments, O's are open spaces that you can enter, and E and X are special locations in the maze. Right? So the original representation is basically going to be as a two-dimensional grid of characters. But once we read that original grid of characters, we're going to turn each one of these characters into an object called a cell. And the first important thing going on in each one of these cells is that, of course, each cell will be storing one of these characters, where the characters are the characters that we pulled from the original text file. In addition to that, the other thing that we're going to be recording in each one of these cell objects is the precise location of that character within the maze. We're going to be recording its row number and its column number as a pair of additional member variables within that cell class. All right, and then finally, the last player in this drama is going to be a path class, because talking about paths is a very relevant concept in this particular application, because after all, our goal is to discover a path that will take us successfully from the entrance all the way to the exit. And along the way, as we've made partial progress and we're partway through the maze, we'll need some way to record what that progress is. Right? So for that purpose, I've introduced a third class, a path class. And the main thing going on in the path class is what you'll see there is basically a list of cells. A path is really nothing more than a collection of cells that you've traveled through. And to record that path, we have an array list inside the path class that keeps a record of all the cells that we have been to so far on our path. Okay, now the way that the lab exercise is going to be structured this week is that I have already given you these three classes, and each of these three classes, of course, will have methods, and these methods are in various states of completion. For example, in the cell class, as we'll see in a minute, I have already filled in all of the methods that you will need in the cell class. So that class is already complete. The maze class is only partially complete. I've filled in some of the methods in this class, but I've left others blank for you to fill in during the lab exercise. And the third class, the path class, I've filled in almost nothing in this class beyond simply setting up the member variable. The only thing I've done here is I have provided a list of methods that we're going to need, but in each case, it's going to be your job to fill in the code to make that method actually work and do what it's supposed to do. Okay, so this is the big picture overview of what we're going to be working with. For this week's lab exercise, I provided you with quite a lot of structure by basically already giving you a set of classes to work with. I've also specified all of the methods that you're going to need in all of these classes, and what you're going to be doing is working within that framework to fill in the logic of all of the missing parts of the methods. Right now, for next week's lab exercise, we're going to be doing something similar. In next week's lab exercise, we're going to be, again, solving a moderately complex problem. And I will be describing an algorithm to you that you can use to solve this problem. But for next week's lab exercise, I'm going to be providing much less structure. I'm not going to be telling you what methods to write. I'm not even going to be telling you what classes you need to create. For next week's lab exercise, it'll be much more of the work will be put on you to determine the overall structure of what you're doing in terms of deciding what classes you'll need and what methods you will need within those classes. Right? But for this week's lab exercise, I have provided an awful lot of structure, which will give you a lot of guidance and a fairly extensive framework within which to do your work. Okay, now what I want to do next is I want to talk about the cell class in some detail because, again, although I have filled in all of the code for all of these methods, I do think it's worthwhile to spend some time talking about what each of these methods does and walking you through some of the code that you see in this class. And also because I filled in some of the code for the maze class, I'll be walking you through some of that code as well. All right, and then after we've had a chance to talk a little bit about what each of these classes are meant to do, the last thing that I'm going to cover today is I'm going to talk about the actual algorithm that we're going to be using to solve the problem of finding our way through the maze successfully. Okay, but before we can get to that algorithm, let's take a closer look at the individual classes and talk about what they are meant to do and some of the specialized things that are going on in these classes. Okay, so the first thing going on here in the cell class, as I've already mentioned, is that each cell basically acts as a container for a character. And that character is designed to tell you what's going on at a certain location within the maze. If that character is an O, that means that this cell is an open cell that you're welcome to walk into. If on the other hand, it's a sharp, that indicates that this particular cell is a wall and you can't enter that particular cell. Right now, one additional feature that we're going to have here beyond those four characters that I've described to you already is that in the course of finding our way through this maze, one thing that we'll find it useful to keep track of is we'll find it very useful to keep a record of all of the cells that we have already entered. Right? And there's one very specific motivation for that, and that is if you don't have a record of the cells where you've already been, then that opens up the possibility that you could find yourself running in circles, right? And the primary way to prevent that and to keep you from running in circles is to keep a record of all of the cells that you've already entered, right? So that way, if you're contemplating entering a particular cell, you can look at your record of which cells you've already entered, and if you notice that this is a cell that you've already entered, you can consciously avoid going into that cell, because what may be happening there is you may be starting to run in circles, which is something that we want to avoid. Right? So specifically to help us avoid running in circles anywhere in the maze as we're going through, another special feature that we're going to be using is that when we enter a cell for the first time, we're going to change the character in that cell from the open character to this so-called visited character. Right? So what we're going to be doing is that whenever we come to a cell for the first time, we're going to be flipping that cell from the open state into a so-called visited state by replacing the O with a V. That puts a marker in that cell to let us know that we've already been there, and that marker will be useful in situations where there's the potential of us running around in circles, and it will help us avoid doing that. Right, so along with this idea of being able to mark a particular cell as visited, I have added a method for that purpose. You can go to a cell and you can call the mark visited method, and what that will do is that will flip the state of the cell from the open state over to the visited state, thereby putting a marker within that cell to let you know that you've been there already. Okay, now, still on the subject of these characters that we're using to keep track of what's going on in the cell, the other thing that I've done here in this class is I have introduced special variables that will basically act as substitutes for those individual characters. Right? So what I've done here in each case where there is a character that represents something that could go on in a cell, I've also introduced a character variable that can act as a substitute for that particular character, right? So here's one example. This is the character variable with the name open, and I'm setting that equal to the character O because, again, in this representation, when you find an O in a cell, it literally means that that particular cell is open and available for you to enter. Right? Likewise, I set up a variable here which is called the closed variable. I set that equal to the sharp symbol, so we can use that word closed as a substitute for the sharp character in our code. And by setting up this system where variable names substitute for the individual characters, the hope is that those variable names will end up being more meaningful than the characters themselves. All right, now, another special thing to notice about the way that I've set up these variables is that all of these variables are set up as member variables. And more specifically, all of these are set up as a type of member variable that we haven't encountered before. All of these variables are going to be set up as what are known as static member variables. Okay, now we've already seen that in classes you can either have a static method or a non-static or ordinary method. Well, the same story applies to member variables. In most cases, when you set up a member variable in a class, it's going to be an ordinary non-static member variable, right? But you do have the option, if you choose to, of setting up member variables that are so-called static member variables. Right? And there's a significant difference between static member variables and ordinary member variables. First of all, when you set up an ordinary member variable, what that does for you is that each time you create an object of this type, you can expect that object to have those member variables in it. Right? So for example, here, when I set up the cell class, what that's saying is that each time that I make a cell object, I can expect that object to have three pieces of information stored in it: a row number, a column number, and a state character. Right? And that's the primary purpose of member variables, is that they exist to give you ways to store data inside individual objects. Right? And ordinary member variables are always very closely associated with the objects that you create. Now, static member variables, on the other hand, are not associated with the individual objects that you create. Instead, static member variables are associated with the class itself. Right? And each time you create a new object, that object will only have ordinary member variables in it, but it won't have these static member variables represented inside the individual objects. Instead, what's going to happen is that anytime you declare a member variable to be static, you're going to have exactly one copy of that member variable within the class itself, and that variable is basically considered to be part of the class, and that variable will not appear inside the individual objects. Right? So the major distinction is that static member variables are associated with the class, and you're going to have exactly one copy of each of these variables, which is associated directly with the class. And ordinary non-static member variables, those instead are associated with the objects. Each object you create will have copies of each one of these ordinary member variables in it. Okay, now the other special thing going on with these variables that I've set up here, beyond declaring them to be static, is I've also applied another special keyword here. I've applied what's called the final keyword to these variables. Now, in Java, whenever you use the final keyword, it's basically a declaration that says, okay, what I'm doing here is I'm setting up a variable, and as I'm setting it up, I'm very consciously giving that variable a value. And this value that I'm about to assign to that variable is what's known as the final value for that variable, which means once that value has been set, you are literally prevented from ever coming along and trying to change the value of that variable. Right? So in this declaration, I'm both setting a value for each one of these variables, and I'm also declaring it to be final, which means that the value that I've just assigned to this variable is going to be the last value this variable will ever have, and under no circumstances will that ever change over the course of the program. Right now, that final declaration, you'll most often see that used in association with a special type of variable that programmers call constants. A constant is a variable whose value never changes. And another convention that programmers are used to using is that whenever they set up a variable that represents a constant, a widely used naming convention that people use is they typically write the names of those variables in all capital letters. That's to help distinguish these things visually from other sorts of variables that you might create. And so whenever you see a variable sitting anywhere in a program and it's written in all caps, that's a very clear signal that this variable represents some sort of a constant, never changing value. And it's unlike other variables, it's never meant to be modified. It represents a fixed quantity which will never change. All right, and finally, my motivation for introducing these constants in this program is to replace the original characters, which might seem a little bit cryptic, with more meaningful terms that more directly describe what these characters stand for. All right, so here I basically noted that O stands for open, V stands for visited, Sharp stands for closed, E stands for entrance, and X stands for exit. And once I've defined those constants, anywhere in the code below where I need to use any one of those values for any purpose, I'm always going to be using the constants and not the equivalent letters. Right? So for example, one of the methods here is the isOpen method, and the purpose of this method is to go to a cell and ask, is this cell available for me to enter? And there are two specific types of cells that you are allowed to enter. One of these is the open cell, and the other one is the exit cell. Although the exit cell is a special cell in the whole structure, it is certainly also a cell that you're allowed to enter, so it qualifies as one of the cell types that you can actually enter. Right? And by using the words open and exit here in place of the more cryptic letters O and E, that makes my meaning that much more clear and helps anybody who's seeing this code for the first time understand more directly what we're talking about here. And that's the eventual motivation for introducing all of these special variables that are equivalent to the letter codes that are being used in the text file. Okay, so that was a somewhat long digression into constants and setting up constants. But again, since this is the first time that we've encountered both static variables and final variables, it was worth taking a few minutes talking about those concepts and explaining why I use them here. Okay, now most of the rest of the code for this class is pretty straightforward, because at the end of the day, this is meant to be a very simple class that simply represents a location within the maze and what's currently going on at that location. And there is a fairly straightforward set of methods associated with this class, allowing you to ask basic questions, like, for example, is this an entrance cell? Is it an exit? Can you tell me what row we're in? Can you tell me what column we're in? And then finally, to facilitate printing, I've also provided a toString method here. This will make it possible for you to take any cell that you like and simply print that, and that gives us a simple mechanism for printing these things in a straightforward way. All right, and then finally, the last thing that I've done here in the class is a practice that programmers don't follow universally, but this is also a very common practice that many programmers use. And that is, very often what programmers will do is, when they're done writing the code for a particular class, they will provide an additional main method in that class. And the purpose of that main method is to run what's called a test program. Very often, when you've written a class and you have sort of a varying level of confidence in terms of how confident you are that the class code is all correct, a practice that you might want to engage in is writing a short test program whose purpose it is to try out some of the methods in the class and see whether or not everything is working the way that you would expect. Right? So that's what I've done here. I've written a very short and simple test program that has absolutely nothing to do with the maze problem. Its only purpose here is simply to exercise the cell class and try some of its methods and confirm that these methods are doing the things that we expect them to do. Right? So what's going to be going on in the test program here is I'm going to be starting out by making a simple cell object. I'm going to be testing its ability to print itself by basically writing some code that would print the contents of that cell. Then we're going to do something to change the state of that cell, and then we're going to print the cell again to confirm that the cell has now been, state has been properly updated. And then we're going to do a similar thing with a second example. Again, create a cell, try printing it, then make some change to it, and then print it again to confirm that everything here is working the way that we expect. All right? And then finally, the last thing you would do is simply run this test program to confirm that everything is working the way that we would expect. All right? So in the first case, we see that the cell correctly updated itself from the open state to the visited state, which is what we're looking for. In the second example, I actually set up a cell that was a cell that you can't enter, and I tried calling the markVisited method, and I noticed that it did the right thing. Instead of declaring itself as being visited, which you can't do in a closed cell, it simply refused to change the state of the cell, and it left the cell at closed, which again is the right thing to do. right? So part of what you're going to be doing for the lab exercise this week is as you finish each one of the classes, you're going to be writing a short test program and embedding that within the class as a main method that will exercise some of these methods and confirm that they're working the way that they should. Okay, so that is the cell class. And again, for the purpose of this week's lab exercise, it has everything you need. I have filled in all the necessary methods that we're going to need. So you won't need to make any changes at all to this class for this week's lab exercise. Right now, the next class we're going to look at is the maze class. And this is a class that I have only partially completed. I've filled in some of the methods, but I've left some of the remaining methods blank, and it'll be your job to fill them in and finish this class. And likewise, I've gone partway through the process of setting up a test program for the maze class. And part of the work that you'll be doing is to actually write some additional code into this main method to test the class further and confirm that it's working correctly. Okay, now the main code that I provided here is code for reading the maze from the original text file. All right, so that code is complete, and what I filled in here is code that will do the work of opening up the text file and creating the grid of cells, and then reading the data that goes into each one of these cells and creating the cells. That code is complete, and that's fully functional, so you won't have to worry about writing the code to read the maze from the file. Likewise, I've also provided some simple code for printing the contents of a maze, so that way you can confirm that what you have read from the file is what you expect to see from the file. Right, and then over and above that, there are some additional methods that you're going to need to write for doing things like locating the entrance in the maze, looking at a particular cell and asking, is there an open cell somewhere near this cell that I can go to? And finally, another method that you're going to need is that if you need to clear the visited state of some particular cell, you can do that by using this method here. All right, so that's the maze class. And again, this is only halfway filled in. You're going to need to fill in the remaining parts. All right, and finally, we have a path class, because again, what we're doing is we're trying to find our way through a maze, and for that, we need a record of where we've been. And most importantly, when you do make it successfully to the exit, the last thing your program will want to do is it will want to print the actual path that will take you from the entrance to the exit. All right, so in the path class, what we have here is a way to have a record of where you've been so far on the path. It's basically an array list of cells. Again, the most important method we're going to need here is the print method, which you'll call at the end, that will be used to print the path when you have succeeded in getting all the way to the exit. All right, and then there are some additional methods that this class is going to need, and your job will be to fill in all the code for the remaining methods in the rest of the class. Okay, so that is an overview of the classes that you're going to be working with. And then the last thing that I want to touch on today is I want to touch on the actual algorithm that we're going to use to find our way through the maze. All right, so to describe that, let's go back to the original picture of the maze and talk about a strategy for finding our way through the maze. All right, so the process will begin by us going to the maze class and asking the maze class to tell us where the entrance cell is. All right, so the maze class will return a cell object to us saying, okay, here's the entrance to the cell. This is where you're going to be starting. All right, and the first thing that you'll do is you'll place that first cell onto your path because you now have begun the process of walking into the maze and traveling into the maze. Right now, what follows is a series of rounds, and on each round, what we're going to be trying to do is we're going to be trying to add to our path. We're basically going to be trying to extend our path from where we just were. All right, and on each round, what we'll do is we'll take a look at which cell appears at the end of the path, and we'll look at the neighboring cells, and we'll ask, is there some place nearby that I can go to next? Right, so if you are at this cell and if you ask the maze class, is there an open cell nearby, it will return this cell to you. All right, and the first thing to do is as soon as you see an open cell to go to is to go ahead and try to travel into that open cell. So what we'll do at that point is we'll add that cell to our path. We'll also mark that cell as visited so that we don't accidentally come back to it later. And then we'll repeat that process. All right, so in the next round, we'll ask again, is there an open cell close to the last cell in my path? And again, the maze will tell us, oh yes, here's an open cell you can go to. So what you'll do is you'll add that to your path and you'll make a little bit further progress. All right, now that process will continue. Again, on each round, the maze hopefully will find an open cell for us, and then we'll go on to that open cell and we'll add that to our path. Right now, that process will continue until something bad happens. The first example of something that could happen to us that could cause trouble is we could discover at some point that we've reached a dead end. Right, so let's suppose that our path now consists of these three cells, this cell, and this cell. And at that point, we once again ask the maze, is there an open cell near us that we can travel to? Right now, it's at this point, the maze should say no, because all of the cells near this cell are cells that are either closed or they've already been visited. So at this point, the maze class will say, no, there are no further open cells in the neighborhood of where you find yourself now. Okay, and whenever that happens, whenever you find yourself in a situation where there is no place for you to go, what that basically indicates is that you have run into a dead end somewhere in the maze. And the correct way to respond to that is to do what's called backtracking. Whenever you do run into a dead end, the appropriate thing to do is to back out of that dead end until you reach a point where you have an option of some place to go. Right. So in this case, what we would do to back out of that dead end is we would remove that last cell from our path and we would backtrack to this location. And from that location, we would ask once again, is there an open cell nearby that we can go to? All right, and at that point, what will be happening is that this cell will have been marked visited, this one will have been marked visited, but this one presumably would still be open. So at that point, the maze will tell us, oh yes, there is an open cell nearby where you can go to. So you'll say, okay, great, let's continue our search from there. Let's push that onto our path and then go back to the process of looking for open cells to go to. Right, so that now gives us the ability to backtrack out of dead ends and walk our way backwards out of any dead ends that we enter and pick up at a new location where we can make progress. All right, and then by combining that backtracking idea with the ability to not go someplace where you've already been, which will keep us from running in circles, the hope is that those two strategies will be sufficient to solve the problem and eventually work our way toward the exit. All right, and eventually you'll reach a point where you'll ask the maze, is there an open cell nearby you can enter? And it will say, oh yes, here's a cell. But when you look at that cell, you'll notice that it's the exit cell. And at that point, whenever you find yourself entering the exit cell, it's time to stop the whole algorithm and declare success. And the last thing you'll want to do at that point is go ahead and print the contents of whatever path you have at the moment and say, okay, I have successfully made it to the exit. Here's the precise list of all the cells you would need to go through to make it from the start to the exit. We now have succeeded in our search. Okay, so that's a lot of information to throw at you, but this is everything that you'll need to know for the lab exercise for this week. Again, it's an overview of the classes you're going to be working with. I've walked you through the strategy that we're going to be using here to find our way through the maze, and your final job will be to sit down and fill in all of the missing details. Okay, so at this point, are there any questions about anything that's going on in anything that I've shown you today? Any questions about any one of the classes that I've shown you or the algorithm that I've just described? Again, any questions at this point about anything that we're doing? Okay, and again, one other thing I'll point out is, as always, I have posted lecture notes. So there are lecture notes posted for what I've covered today. There are also, of course, the materials for the lab itself, and you'll want to review both of those in preparation for the lab tomorrow, because both of those are relevant to what we're doing. All right, and finally, a word about how we're going to be going about doing the lab exercise tomorrow. Tomorrow, we're going to be trying a little bit of an experiment in group work. What I'm going to give you the option of doing is working on this lab exercise with a partner. What we'll do at the start of the lab period tomorrow is I will basically ask for people who would like to work with partners, and I'll be trying to divide you up into groups of 2. And then during the course of a lab exercise, you'll be working in combination with a partner. Probably the way that you'll have to organize this is that you'll have to decide which one of the 2 of you will be doing the actual coding and the actual typing of the code. And for most of the lab exercise, that person will be typing up everything with the assistance of their partner, who's going to be sort of watching and advising and discussing with you how to approach filling in the various parts of the exercise. Right, and of course, as always, I will be available for the entire duration of the lab exercise. So if you would like to come and talk to me and ask me questions, as always, I'll be available to answer questions. All right, and one final thing to say is that although this is going to be set up as a partner exercise, that aspect of the exercise is also optional. If you would prefer instead to do the exercise on your own, you're certainly welcome to do that. But if you would prefer instead to work with a partner, you're very much going to be encouraged to do that. Okay, so that's everything I have for you. That sets everybody up ready to do the lab exercise. So I will see everyone back in the lab exercise tomorrow. And then on Friday, when we come back, I will be showing everybody my solution to the lab exercise, and I'll be talking about that. Okay, so until then, hang in there, everybody. We'll hope to see you all back in the lab exercise tomorrow.